Okay, example 2, same thing. I'm not going to write this out. We're just going to graph 2 periods of each function. Okay, so I'm going to look at y equals negative tangent of 2x minus 2. Okay, so I've got A here, I've got B, right? I don't have an H, but now I have a K. All right, so again, my amplitude in quotations, because it's not really an amplitude, is 1. Okay, my period is pi over b, so it's pi over 2. Okay, that means that the distance, right, between my critical points is pi over 2 divided by 4, so that would be pi over 2 times 1/4, so it's going to be pi over 8. Okay. All right, so if I need to graph 2 periods of this, okay, I've got my first period at pi over 2. My second period, pi over 2 plus pi over 2, is 2 pi over 2, which is pi. Okay. Okay, that means that the distance between intervals, right, is pi over 8. So this would be pi over 8. This one is 2 pi over 8. This is 3 pi over 8. Okay, this is 4 pi over 8, which is pi over 2. This is 5 pi over 8. This is 6 pi over 8. And this is 7 pi over 8. And this would be 8 pi over 8. Okay, 2 pi over 8 reduces to pi over 4. And 6 pi over 8 reduces to 3 pi over 4. Okay, I do have, right, this vertical translation here, which means that my midline, okay, I've got a shift. My midline is no longer my x-axis. It is shifting down 2 units. Okay, it's shifting down 2 units. Okay, so looking at my parent function, right, for tangent, the first point is at 0, okay, on the midline, right? So at 0, it is on the midline. Okay, so my first point here is going to be 0 right there. Okay, my second point goes up, should go up 1 unit above my amplitude. But, right, I have this reflection. It's being reflected across that midline. So my second point, or my second critical point, is going to be 1 below, okay, that midline. Then I've got an asymptote. Okay, and now I'm going to keep going. Okay, at my next critical point, I should be 1 point above the midline. At my next critical point, I'm on the midline. And then at my next critical point, I'm 1 unit below the midline. Okay, and this is all reflected, right? So normally, I would be, right, 1 unit below, at, above. Okay, my graph would be going this way. Okay, but in this case, since it's reflected, it's different. Okay, and then I finish here. I've got 1 unit above and at the midline. Okay, so the graph of this function looks like this. Okay, and again, you can graph this using a table if you would like to. Okay, if that's less confusing. you can take values and you can plug them in for x. Okay, you want to use your critical points. And I would just do one period because then it's just going to repeat, right? You can plug your points in for x and then get points on a grid, right? And you're going to use your critical points here. Okay, and you can plug those into your function and get points out, and those will be the points that you're plotting on your graph. Okay. Let's say that we have y equals the cotangent of x minus pi over 2. Okay, so now we have a phase shift, and that's the one that usually throws a kink into everything. This, we don't have to factor anything out, so that's nice. Okay, here's my A. B is 1. My phase shift right is H. That means this graph is shifting right, and I don't have a K over here. All right, so my amplitude, okay, is 1. Okay, my period is pi over 1. Okay, or just pi. That means that my distance between my critical points, okay, is going to be pi over 4. Okay, I do have a phase shift, right? So I'm going to start my graph at my phase shift. My phase shift goes right pi over 2 units. Okay, so I'm going to start at pi over 2. That means the end of my first period is going to be pi, but then I have to shift that over pi over 2 units. So that's 2 pi over 2 plus pi over 2. So that is 3 pi over 2. All right, so here's my cotangent graph. Okay, my first period is going to end at 3 pi over 2. Okay, that means 3 pi over 2 plus 3 pi over 2, okay, is that is 6 pi over 2, but that's not going to be the end of my second period. Okay, so there's the end of my first period. Now I need to lay out all of these critical points. I am starting, okay, at pi over 2, and the distance between my critical points is pi over 4. Okay, so now it's not quite as easy. So pi over 2 plus pi over 4. So I have 2 pi over 2, sorry, 2 pi over 4 plus pi over 4 is 3 pi over 4. Okay, plus, right, 3 pi over 4 plus pi over 4 is 4 pi over 4, which simplifies to pi. Okay, pi over 4. So I'm going to write pi as 4 pi over 4 plus pi over 4 is 5 pi over 4. Okay, and I didn't put enough marks in there, so this is 5 pi over 4. Okay, my next one should be the end of the period, which should be 3 pi over 2. Okay, but let's check. So I have 5 pi over 4 plus pi over 4 is 6 pi over 4, which is 3 pi over 2. Okay, then I go to find my next critical point. Okay, 3 pi over 2 is 6 pi over 4 plus pi over 4 is 7 pi over 4. Okay, and I'm going to keep going, or I need to keep going. I'm going to go ahead and just fill the rest of these in. This is going to be 2 pi. This is going to be 9 pi over 4. And this one is going to be 5 pi over 2. Okay, so I am graphing the cotangent function. So if I look at my parent function at my first critical point, I've got an asymptote. Okay, I don't have a reflection here, so at my next critical point, since my fake amplitude is 1, I'm 1 unit above the midline. At my next critical point, I'm at the midline. And at my next critical point, I'm 1 unit below the midline. Then at the end of my period, I have another asymptote. Okay, and then the pattern repeats. Okay, at my first critical point, I'm at the amplitude. At my next critical point, I'm at 0. And my next critical point, I'm 1 unit below the amplitude. And again, remember, it's not really an amplitude. Okay, I'm just calling that because it kind of works like that. And so my graph looks like this. Okay, once again, you can graph this using a table if that's easier. Okay, so you can graph it just knowing how the cotangent function works, or you can graph it using a table.